Okay, while we're waiting for people to get into the classroom and for everybody to get their questions ready, I'll talk a little bit about test one. So I did finish grading the tests. That was an awfully long pause, right? I finished grading the tests last night. And while you will see a test grade in my stat lab, the adjusted test grade, that would include any bonus points you earned for the homework, for getting your homework up to 90%, or if you got any bonus points on the test itself, then that will be reflected in your Blackboard grade. If you want to look and see anything, see why you missed something or any comments or feedback I gave on your work, then you do that by going to your grade book in my stat lab, not the assignments, but the grade book in my stat lab, and click on review next to the test. And then if you go to the individual questions where you are required to show work and click on show work, you'll be able to see any questions or feedback or anything that I gave on there. Okay, a couple of things about the way I graded it. There were 2 bonus questions on there. One of them I forgot to have you have the show work thing. I have to click on something in order for the show workspace to become available to you. I forgot to do that on one of them. So if you got that one right, you got the points for it. Now you'll notice everyone should see that on those 2 bonus questions, because I didn't want it to count against you, it'll say you got the 1 point for that bonus question. Whether or not you did it, whether or not you got it right, it's going to show that you got the 1 point for that, which basically I worked it out for most people. That ended up giving you about 5 points on your test grade, but I'm okay with that. So everybody kind of got 5 points, kind of a 5-point curve, up 4 to 5 points. Everybody got a 4 to 5 point curve on their test, no matter what, because I counted those 2 as 1 point credit on the test for everybody. But if you actually got them right and showed the work on the one that you could show work on, then you may have gotten extra points. So if you see your grade in Blackboard, your test grade, is higher than what it's showing in my stat lab, that's going to be for one of two reasons. Or I think I had 1 or 2 people got both the 5 points for having all their homework up to 90% and got some bonus points, a few bonus points for 1 or both of the bonus questions on the test. Another issue on the test, there was a problem, you guys may remember this. It was kind of a long problem on creating a frequency distribution, and you had to show work to find the class width. And that was the only thing I asked you to show in the show work. So I had to see where you actually calculated the class width correctly using the correct formula in order to get full credit. On that particular problem, one of the data values went missing. Some of you figured that out because you opened up StatCrunch and you saw that there were supposed to be 20 values, not 19. But basically what I did was I looked at what you did. I could see what your answers were behind the correct answers. And so I could tell if you were basing it on what you saw and did not refer to StatCrunch where all 20 values showed. And so I would have given you credit for it. And I wrote you a note that said, you know, I know they counted some things wrong, but that's because you couldn't see a data value, so I've graded it according to what you could see. That problem was worth 10 points. That problem was worth more than any other problem, which was why before the test, I told you guys to, I told you one to look at in the homework to prepare for that one problem. Hopefully some of you did that. Maybe some of you, I had a few people get it completely right, and maybe that's because they went back and did that one problem I suggested that you review. Always, if I send you an email and I say, hey, you should look over this question, before taking the test, or I'll probably do another proctorio practice quiz before the next test, and you should pay attention to the problems that are on that and make sure if you get them wrong that you figure out how to get them right. What I did with the proctorio practice quiz this time is, for those of you who did it, you got an extra 100 as a quiz grade. So your quiz average, if you were looking at your quiz average, if you're checking Blackboard a lot, you may have noticed your quiz average went up a little bit. It generally added about 1 point to everybody's quiz average who had done the proctorio practice quiz. And then if you had not done the proctorio practice quiz, I just didn't count it as a quiz grade for you. So, and I don't do that very often, but I did that on this one. Trying to think. Oh, another weird one was the circle graph on the test, because if you got it partially right, it did not give you partial credit. So, you had to click on the different things that were true about the circle graph, and you could have gotten both. There were 2 things you were supposed to click on. You might have clicked on both of those, but if you clicked on a third one that wasn't correct, it counted the whole thing wrong. So I went back and I gave partial credit on that one problem if you got part of it right. Right, so that's all I can think of right now. That was a little weird, but if you guys have a question, any questions about it, then I certainly will address that, or you can wait till the break to ask me. That will be fine too. And we are going to today I'm going to start with questions from 3.1. But if you have a question about the test, you're afraid you'll forget and it's pretty quick, you can go ahead and ask that also. So does anybody have a question from, it could be from the test or from section 3.1 in the homework? Can everybody hear me? Hopefully, I haven't been talking for nothing, have I?
We can hear you.
Okay, good. I thought, oh man, I hope I don't have to repeat all that stuff. All right, so any questions, or did anybody have any trouble with Chapter 3 skills review or the 3.1 homework? If not, we're going on to 3.2. If you look at your checklist planner, let's look at that for a second just to make sure we're staying on track. So I think I have it here. So here's our checklist planner for Unit 2 over Chapters 3 and 4. And you can see we're on Monday, September the 28th. And today, all we're going to do is Section 3.2. So that's not a whole lot, but there are a few important concepts in there. I thought we would start, though, with sort of a review of basic probability, which is what we talked about last time, and about the notation and stuff like that. Okay, so any questions from 3.1 or the test before we go on to 3.2? All right, let's review quickly what we learned last time when we did our introduction to probability. First, let's review again probability notation. If we want to talk about the probability of event A, we write it like this. It's sort of like if you took algebra, if you ever took algebra, it looks a little bit like function notation, like f of A. But in probability, this means the probability of event A occurring. Let's do some simple probability just for practice. I generally ask questions about drawing cards out of a deck of cards because there are a lot of different possible outcomes, and so it makes it kind of a good example to use. And let's do something really simple. Let's suppose our experiment is just drawing one card, and we wanted to know what's the probability that that one card we draw is a king. So I have a picture of a deck of cards on the sample space work handout that's in your Unit 2 folder for you to print off, and which I expect you to use on the test. I have one picture of it, but I have another picture that's, I think, even better. I found this one online, and this is what a deck of cards looks like. So if you don't know anything about cards, you might look over this, make sure you print off that sample space handout. A couple of things on the handout you might write down, like that the hearts and diamonds are red and the spades and clubs are black, considered black cards. An ace is like a 1. At the end, over there on the end of the of each row, let me get this little hand. Over here at the end of each row, you'll see this is called the Jack, Queen, and King. And those cards are also called court cards, like a royal court. So if I was going to do the probability of drawing a king, if I'm drawing one card, then the basic probability formula is, and we're doing theoretical or classical probability here. So we're not actually going to draw a card a bunch of times and see how many times we pick a king. We're not going to do that. We're just going to theoretically say, okay, well, the total number of possible outcomes is 52. You should write that down for cards. Our bottom number is 52. So remember the way we do probability. I'm going to unshare that so the people watching the recording can see this. So when we do the probability of A, on the top, we put how many times A happens in the sample space. So number of times A occurs in the sample space, or the number of outcomes that are described by A. Sometimes you can say the number of times A occurs. That's the number that goes on front, on the top. So on ours, when we do the probability of drawing a king, that would be the number of kings in the deck. So we're counting how many times this occurs in the whole sample space. And then the denominator is the total number of possible outcomes. So on ours, if your sample space, if your experiment is drawing cards from a standard deck of cards, that denominator is always 52 because that's the number of cards in a deck. Total number in a deck of cards. So you definitely need to know that, make note of that. That would be something you would want to include on your sheet that you were using. So going back to that sample space, the deck of cards, to get our top number, we're going to look at this deck of cards and count how many times king occurs. You'll see that the kings are all at the end. They're the ones with the K on them. And you can see that there's 4 kings, 1 in each suit. So our top number then becomes 4. Our top number becomes 4, and our bottom number is 52. So that 4 is the number of kings in the deck. Now we don't leave it like this because those are both even numbers. We are going to write our answers, our probabilities as fractions. Usually fractions are decimals. Every once in a while they'll ask for a percent, but most of the time it's fractions or decimals. You need to pay attention to the instructions that they give you in My Stat Lab. Make sure you put the answer in the form that it's requesting. Otherwise they'll count it wrong. So I can divide, actually 4 and 52 will both divide by 4. But if you didn't realize that, you could divide by 2. That would give you 2 over 26. And then you could divide by 2 again, and that would give you 1 out of 13. And that's the probability of drawing a king. Let's do one more before we go on to what we're going to talk about today. So what if I said, what's the probability of drawing a heart? And I could write the word heart, or sometimes we just use abbreviations for it. So I'm just going to put a heart. The probability of drawing a heart. We know the bottom number is 52 because we're still drawing a card from a deck of cards. The top number is going to be how many hearts there are in the deck. So you would look at your deck of cards. You see the hearts are the second row, and you would count how many there are. So you see we have the numbers 1 through 10, then 3 court cards. So there's 13 cards total in each suit. Okay? So, and we have 2 red suits and 2 black suits. Another thing you should notice is that half the cards are red and half the cards are black. But this one says the probability of drawing a heart. So our top number is going to be, there are 13 hearts, the ace through 10, and then the 3 court cards. So there are 13 hearts. And then we would reduce this. 13 goes evenly into 52 4 times. And so this would reduce to 1 out of 4, which should make sense because a fourth of the cards are hearts. It should make sense that the probability of drawing a heart is 1 out of 4. So that was basic probability that we learned last week, last Wednesday. Does anybody have a question about any of this before we go on? Okay, then let me erase this, and we're going to go on to some new topics in section 3.2. So this is where the 3.2 notes would start. And there are a couple of important thoughts, ideas, topics in 3.2. And the first one we're going to talk about is independent versus dependent events. And this is when you have 2 events. They could be going on at the same time, or they could be sequential. For example, I could be drawing a card from a deck, and at the same time, or sequentially, rolling a die. Okay? Now, so you have this deck of cards. So imagine your deck of cards, okay? And then you have your die. Now, what we draw out of this deck has absolutely no bearing on what we roll on the die. These 2 things aren't connected in any way whatsoever. Okay, so we call these 2 events would be independent. Drawing a card and rolling a die, those would be independent events. They are independent of each other. The outcome of one does not affect the probability of the other at all. All right? Some other examples of things that are independent. Well, we'll decide whether it's independent or dependent. Now let's make it a little bit more interesting. Suppose you're going to draw 2 cards from the deck of cards. Not at the same time, sequentially. And we're going to look at that 2 ways. So the first way, so we draw 1 card and then we draw a second card. So these are like 2 separate events, kind of like this. And we're going to look at this 2 different ways. The first way we're going to look at it is with replacement, because you're going to see these words on homework problems. I want you to know what that means. So if we say drawing 2 cards sequentially with replacement, that means we draw the first one and then we draw the second one, but we put the first one back. So we draw the first one, look at it, stick it back in, and then we draw the second one. Now, because we put the first one back in, we're just starting over from scratch the second time. And what we drew the first time is not going to affect what we draw the second time, because we're starting all over again. So this would be these events. In this case, these would be independent draws or independent events. But what if after we draw the first one, we put it down somewhere, or we hold it behind our back, and then we draw a second one? Well, that's going to affect the probability that on the second one, because for one thing, there's a card that's not there anymore. So now you don't have 52 cards, you have 51 cards, and there's one card, the card that's missing. So say it's a heart, then that would affect the probability of drawing a heart the next time, because there's one less hearts as well as one less card in the entire deck. So when we don't put it back, the phrase we use is without replacement. And if we don't put that first one back, now what we drew the first time affects the probability on the second draw. That means these are not independent events. These are dependent events. Because what you took out the first time affects the probability of what you'll get for the second draw. I'm going to give you, I have a couple of things I want you to consider. Whether these are, so what we're trying to decide is whether these are independent or dependent, okay? So independent versus dependent. I'm going to give you 2 examples to consider, and then I'm going to check roll while you're thinking about it. So example 1, example 2. And so they're going to give you some weird ones. I mean, this is like a probability experiment. You draw a card and then you draw another card. But sometimes they're just going to give you 2 ideas. They want you to think about, are these independent or are they dependent? Does the probability of one thing affect the probability of the other? Or does the occurrence, really we should say that, does the occurrence of one thing affect the probability of the other? So, one pair of things I want you to consider, are these independent or dependent, our birth month and IQ. So I want you to think about these for a little bit, and then after I check roll, we'll come back and talk about them. And the second thing, speeding and getting a ticket. Now let me remind you of how you're thinking about this. You have to consider, will the occurrence of one thing affect the probability that the other thing happens? That's how you decide. And if it does, or if it can affect the probability of the other thing, they are dependent events. If one thing has absolutely nothing to do and cannot in any way affect the probability of the other thing, then they are independent. So think about this while I check roll. Please raise your hand when I call your name. Ariana? And leave it up until I'm done. Diamond, thank you. Cecil? Kayla? Christina, Layla, Mia, Ricky, Samira, Stephanie, and Layla. Are you there? Raise your hand if you're there. Okay, thank you. All right, guys, you can all put your hands down. Okay, back to this problem. We have to decide on number 1. You can type in the chat or turn on your microphone. Are birth month and IQ dependent or independent events? So Ricky is saying independent. Right, those are independent. We might like to think that because we're born in a certain month, that means we're automatically going to have a higher IQ, but that's not the case. All right, so those are independent events. What about this one, speeding and getting a ticket? Can the occurrence of one thing affect the probability of the other? Dependent? Those are dependent, yes. So notice it doesn't have to be a for sure. Like people sometimes speed and don't get a ticket, right? But if you speed, it does affect the probability of getting a ticket, right? So just like if you park illegally, it increases, it affects the probability of getting a parking ticket. So all it has to do is possibly affect. Whereas the month that you're born in doesn't possibly affect your IQ. There are other things that might affect your IQ. I don't really know what they would be, but the month you're born in isn't one of them. So, but if you are speeding, you're definitely increasing the probability that you'll get a ticket, a traffic ticket. Okay, so you're going to have some problems like that in your homework. Right. So I'm going to erase this and we're going to talk about another thing. I'm leaving that up there for a reason. So we're going to refer to that. So the second thing that's going to be new in this is something called conditional probability. Conditional probability. And I've misplaced, oh, there it is. First of all, let me show you the notation for conditional probability, and then we'll talk about what it means. For conditional probability, you have to have two events happening sequentially. And this is what the notation looks like. I'm going to write underneath this how you would read this, okay? So that straight bar there, that's not a 1, that's just a straight bar, okay? So, of course, this means the probability. When you get to the parentheses, that means of. Let's call that event B. So the probability of event B occurring, and then that straight bar represents the word given. event A has occurred. Let's look at that again. This is the notation for conditional probability. So conditional probability is a thing that you can consider if you have a sequence of two or more events occurring. So for example, drawing two cards sequentially. That would be a situation where we might have a conditional probability. So I'm probably going to use one of these examples, one of these two things, and talk about a conditional probability. So when you see this notation, the probability of B given A is one way to read it, but if I want to be very exact about what that means, this means the probability of event B occurring given, or you could even say after, okay, if you wanted to say after, that will usually work also. Given or after event A has occurred. In other words, you know event A has occurred, and the question is, what's the probability now that event B will occur? Okay, so I'm going to use this drawing two cards sequentially as an example to try to demonstrate how you might do a conditional probability. So we're drawing two cards sequentially. Let's suppose we wanted to know what's the probability that we get a queen on, I'm going to put a little 2 here, a queen on the second draw. I'm going to put a little 2 there so we'll know that's the second draw. Given that we got a queen on the first draw. And let's say we're doing it, we're drawing two cards. And let's do this one. Let's do without replacement. So we're drawing two cards without replacement. That means these are dependent events. That means what happened on the first draw is going to affect the probability on the second draw. So this is asking, what's the probability we get a queen on the second draw? That's really the question. What's the probability of getting a queen on the second draw? But it's telling you that something else already happened. Okay, so this is telling you a queen was drawn, was already drawn. And since we're doing this without replacement, so a queen was already drawn and not replaced, not put back. Not put back. So that changes the sample space, right? So this is called the condition. The condition is that a queen was drawn on the first draw. The question is, knowing that, what's the probability you'll get a queen on the second draw? So let's think about this. So the thing that we know already happened is this. This is the condition. Or the given. It already happened. So if we already picked a queen on the first draw, first of all, there are fewer queens, right? So normally we would do the number of queens over the total number, which would normally be 4 out of 52. 4 queens out of 52 cards. But now we know a queen was already drawn. So how many queens are left? What's our new top number going to be? We know we already drew a queen and we didn't put it back in. So how many queens are left, guys?
Three out of 51.
Right, Mia. 3 out of 51. 3 because there's 1 fewer queens, and 51 because there's also 1 fewer cards. So the probability of drawing a queen on the second draw, knowing, you can think of that too, that given, that bar, you could also think of it as the word knowing. Knowing that you already drew a queen and by the experiment did not put it back. Okay, so that means there are 3 queens left and 51 cards total. Now, if you wanted to know if this would reduce or not, that's only going to reduce if 3 goes evenly to 51. So let's take our calculator and say, well, will 51 divide by 3? And yes, it does. That means that that simplifies. 3 goes evenly into 51 17 times. So if I divide the top and bottom by 3, I get 1 out of 17. So this is kind of the same thing, isn't it, of saying what's the probability of getting 2 queens in a row if you're drawing 2 cards without replacement. So that's one way to look at it. Now I wanted to look at a problem in your homework. If you have my Stat Lab open on your device, open up your homework. I'm going to give you a minute to do this because I'm going to take a minute to pull mine up. And the one I want you to pull up is problem number 5. And it's going to take me a minute to do it, so you have some time. I want you to go to problem number 5 in your homework. And I'm going to do the same. I'm going to open up my Stat Lab on this device. You guys do the same if you can. If you can sign in to another place, then do this with me, okay? And we're going to the 3.2 homework. We're going to look at problem number 5. Now, if you notice on this one, if you're looking at it, and I'm going to show you this. Let me see if I can share this with you. So this is problem number 5 in your 3.2 homework. In case you can't open it, I wanted to show you what it looks like. It says the accompanying table shows the numbers of male and female students in a particular country who received bachelor's degrees in business in a recent year. It says complete parts A and B. So notice it says click on the icon to view the data on the business degrees. Now when I click on this, you're probably not going to see that table, but I'm going to try to share it with you so we can look at it. So, oh, maybe you can see it. Can you guys see it?
Yes.
Okay. So if you notice, they've given us a table, and it's divided up between business degrees and non-business degrees, male and female. So and it gives us quite a bit of information. So it tells us how many male, and I think I'm gonna take a picture of this so I can write on it. tells us how many male and female business degrees and total business degrees. And then it tells us male and female non-business degrees and total business degrees. This total over here, that's 786,353, that's the total males. The 1,033,337, that's total females. And then down here, you can see the total of all the people, males and females, is 1,819,690. That's your total people. So that would be like your bottom number. So I'm going to write a few things on here. I can see that my total number, I'll write that total is 1,819,690. And I'm going to write the A part on this. It says find the probability that a randomly selected student is male. So I'm going to put an M for male. Given, so that's that bar, the student received a business degree. So on your probability statement, that's going to look like the probability that they're male given that they received a business degree. Now remember, the given, like this thing already happened. So if we're given that they already received a business degree, look at the people that received business degrees.
Miss Haley, can you unshare that so we can see what you're doing on the board?
I'm going to. I just need these. I'm just going to get the number off of it and then I'll unshare it. Okay. So notice I need that number. So given that they received a business degree, I need to know how many received business degrees because those are the only ones we're looking at here. Do you guys see those? 360,000. Let me write that number down and then I'll unshare. 360,754. 360,754. And of those, I also need to know which ones are male and female. Okay. Male is 181, 385, and female is 179, 369. So I'm just trying to write some of that stuff down so we can work the problem. Hold on just a second and I will unshare that. Okay, so first, this is how I wrote the probability for this question. So this is the probability that a randomly selected person is male given that it's someone with a business degree. So this here, that's your condition. That means that has narrowed the sample space. Do you remember on that last one we did, we said we'd already drawn a queen? And that narrowed your sample space to 51. So you didn't use 52 because you already knew a queen was drawn, a card had been drawn and not put back. In this case, our condition is that a business degree. We already know that. That reduces the sample space. These are the only people we're going to consider. Only ones considered. because that's given. We already know the person had a business degree. So that means that was this number right here. That means we're only looking at these people. So we don't need this number. The condition narrows the sample space. Because if we already know they got a business degree, we're not even looking at the ones that didn't get a business degree because this condition was given. It already happened. We already know that this randomly selected person got a business degree. That means we know it's one of those 360,750 people. We already know that, so we don't even have to consider the rest. So it narrowed our sample space. We don't need to consider that total because this was given. This becomes the new bottom number. So now we want to know, now that we've narrowed it down to this, what's the probability that they are male? So now we look at those that are in my given set that meet the condition that I know already happened. I already know I'm in this area. And now the question is, from that, what's the probability that they're male? I only look at the ones who meet the condition, and now I want to know what's the probability that they're male. Well, they told me how many are male out of those. So the probability that they're male, then that we already know they have a business degree, is, so I put my total number is going to be that new sample space that meet the condition. So the condition tells you what your sample space is. It narrows it down. So you're only looking at this set. And then out of those, I need to see how many were male. So I'm looking at these 360,754. Out of those, 181,385 were male. Now, chances are they're not going to expect us to reduce this fraction. They probably tell us to change this to a decimal, but I'm going to look at that and make sure. So hold on just a second. I'm going to see if they I was hoping it was still there. Does anybody have theirs open? Can you tell me what it says for rounding?
Round to the third decimal space.
Okay, so we're going to do the division. I'm going to divide that top number by the bottom number. 181,385 divided by 360,754. You guys do this with me. And what I get is 0.5027. If I'm going to round to the third place, I only need to take it out 4 places. And that's so I'll know what to round. This is my rounding place. So if I'm rounding to 3 decimal places, I'm going to make that 0.50, and I'm going to round that up to a 3 because the next number is 5 or bigger. And that would be my answer to that one. So what I want you guys to do is I want you to look at that question, and I think there's a B question as well. I'm going to look at it on my laptop instead of that device. Your numbers won't be the same as mine, by the way. You'll probably have different numbers over here. It might be the same question, but you might have different numbers in your table. So you have to open up the table to see your numbers. I'm going to do this on mine. Try doing the A and the B part for number 5 while I pull mine up. So when I did a new one, it did Okay, it was the same question, but it does look like the numbers are different. And I'm going to go ahead and answer my A part so I can see what the B part is. Did everybody get your A part? Raise your hand if you were able to look at number 5 and you got the A part right.
I haven't finished with mine, at least.
Okay, thanks, Kayla. I'm going to give you a minute or two to finish the A part of number 5, and then I'm going to do the B part with you. Okay, Kayla, did you get it? Did you get your answer right?
Yeah, I've got the part A right.
You got the part A right? Good. Has anybody else gotten part A right? Christina, good. Ricky, very good. Y'all want to look at part B now? I'm going to put the work up here for part B. I'm not going to do anything besides this before the break. We'll do the last part after the break so that you can focus. Now, if you try to do the problems in 3.2 in order from beginning to end, they're kind of mixed up. So some things I haven't talked about yet. So don't worry about that. You can flip through and try to do the ones that you can. And then if I don't address the ones you had trouble with, we can go over that when I finish teaching the section. So Ricky, did you get it right or did you have a question? Terrific. Okay. On mine, my second question says, what's the probability that they got a business degree given that they're female? Probably your question is the same, just your numbers are different. Does it look like it's the same? Those of you who are looking at it, does it look like your second question is the same as mine? What's the probability they have a business degree given that they're female?
Yes, the same.
Okay, so remember, this is your condition. That's like what you already know. That tells you what your reduced sample space is. So what I'm going to have, that means for my bottom number, that's my reduced sample space. So what I need for my bottom number is just all of them that are already female. Number of females. So on this one, my bottom number was the condition, the number with business degrees. Do you see how the condition tells you what the bottom number is going to be? And then that's your new sample space. So now I'm only going to look at the females, and I want to know out of those, how many of them have business degree. So this is going to be the number of females, because that's all I'm looking at, with business degrees. And I have, the one I have here has different numbers on it. So I'm only looking at the females. I'm going to open up my table on my laptop here. Now I'm only looking at the females. So on mine, the females are like the second row. And the ones that have business degrees are 161, 913, non-business, and then the total females is 1,000,000. And actually, I don't really care what the non-business is, but I could put it there if I wanted to, 878. Now, because my condition is this is the condition. That's the thing I know has already happened. That means I'm only looking at females, and all the females are on this row. These are females with business degrees, females with non-business degrees, and those two added together would give you that total for total females. So that's the only row I need to answer this question. My total number of females, because that's my condition, my given, my already happened, is that 1,040,479. And of those, the ones that have business degrees are the 161,913. And again, we're going to do that division to find the probability. And this one wants us again to round to 3 decimal places. So on mine, I get 0.1556. So I'm thinking on mine is 0.156. So during the break, guys, I'd like for you to go, if you're not already in my stat lab, go to my stat lab and do this problem. This is 3.2, number 5. There are other ones that you can do, other ones I'd like for you to try during the break. Don't do number, I wouldn't do number 4 because I haven't talked about that yet. There's a bunch of them that say independent or dependent, so you can flip through those and do the ones where they ask you if things are independent or dependent. I've taught that. There's a bunch of those. Might try number 10. So try number 5 and try number 10 during the break. And then also flip through and practice doing dependent versus independent events. And I will see you back at noon. If you have a question about the test, hang on.